Welcome to the course on biostatistics and design of experiments. Last class I introduced the terminology called ANOVA. We will continue on that same topic. ANOVA is nothing but analysis of variance. So, ANOVA makes use of the F-test. Basically it does a F ratio calculation, so that is the S1 square, that is variance from sample 1 divided by variance from sample 2. So, the null hypothesis will be the variances of the populations are equal, the alternate could be, this could be different, or sigma 1 square greater than sigma 2 square and so on. So, we also have a table, F table. Okay. So, if the F value calculated is less than the F table, we do not reject the null hypothesis, we accept the null hypothesis. If the F value calculated is greater than the table, we reject the null hypothesis and hence accept the alternate hypothesis. Now, I also mentioned the degrees of freedom for the numerator will be n1 minus 1, where n1 is the number of data points for the numerator sample, and degrees of freedom for the denominator will be n2 minus 1, okay, where n2 is the number of data points for the sample 2. And then so you have tables for a p is equal to 0.5, that means 95% confidence. We have a F table, this is for the numerator and this is for the denominator. So, this if you look at the next page, it continues like this. So, you select the F value. So, this is for p is equal to 0.05, similarly we have p is equal to 0.01 and so on actually, okay. For any value of p you will be able to get it. Now, we also have the Excel function. There are two Excel functions, one is called the F-dist, other is called the F-in. So, F-in is exactly like your F table. Given the probability, I put in say 0.05, give the numerator degrees of freedom, denominator, it gives you the F value. So, if you do not have the table, we can use the F-in function. Now, F-dist, okay, F-dist gives you the probability, where here I put in the ratio, okay. If I put in the ratio, that is F ratio, give the degrees of freedom for numerator and denominator, it calculates the probability. So, we have both functions available in Excel, so we can make use of it. So, as I said, F-in is exactly like your F table, whereas F-dist calculates the probability, and if the probability is high, greater than 0.05, generally there is no reason for you to reject the null hypothesis. And similar to this, we also have the graph pad also has got both the options. I showed you in the previous class. When I come and start doing new problems, I will show you in this present class also. So, we introduced the concept of ANOVA. ANOVA is nothing but analysis of variance. So, we are taking a ratio of two variances, one is between group variance and within group variance. Suppose I am comparing two drugs, so between group variance will be comparison of variances between drugs. So, within group variance is nothing but error. So, if there is a lot of variation within the group, obviously the within group variance or error variance will be very large, that means denominator will be very large, then F value will be small. So, I will not be able to differentiate between two different drugs, for example, okay. So, that is an important point one needs to keep in mind. So, when I am repeating experiments, for example, different operators, if they consistently they are is good, then obviously the error variance will be good. If the error variance will be low, that means the F value will be high. If there is a lot of variation or standard deviation, then obviously the error variance will be large, F value will be small. So, obviously we will not be able to reject the null hypothesis. Then I mentioned something called one-way ANOVA. Let us look at some problems here. So, we have male and female rats, they are given hypnotic drug and the number of minutes they slept in minutes are recorded, okay. So, male rats they took 5 samples here, female rats they took 5 samples here, and these are the time they took, so many minutes they took to sleep, okay. So, obviously I want to know if the female slept longer than the males, okay. So, the numerator in the F value will be between groups, that means between male and female, within groups will be this. So, the variations happening here, that will come in the denominator, and the variations between these two groups will come in the numerator. So, we need to do some calculations and then finally divide one set of variance with the another set of variance. So, it is quite simple, let us do it very systematically. Okay. So, there is 3 different variances you need to calculate. Okay. The total sum of squares will be between sample sum of squares. Between sample means between here groups, the male and the female, plus within sample sum of squares, that is within this. Okay. Because as I said, when we calculate f, we do a between sample divided by within samples. Okay. We will do between sample variance divided by within sample variance. So, if I calculate sum of squares, if I divide by degrees of freedom, that will give you the variance. If I calculate the sum of squares within sample divided by its degrees of freedom, I will get the variance. So, total sum of squares will be sum of these two. How do you calculate total sum of squares? Summation of x is any of the value divided by x double bar. X double bar is overall mean. You will have a mean for male, that means if I add these 5 and divide by 5, I will get some mean, right. I will call it x bar s. So, I will have a mean for x bar, I will have a mean for female, I will have a mean for male. If I take mean of these two means, I will get total mean, overall mean, or I add up all these and I divide by 10 also, I will get overall mean. So, the number of data points is 10. So, the total sum of squares here can be easily calculated. So, I will take a overall mean, that means I take a mean for male, I take a mean for female, then I take a mean of these two means, that will give me the overall mean. Okay. X minus x double bar square summation, that is called the total sum of squares. Now, you understood how to calculate that. Okay. Now, between sample sum of squares, between samples. So, there is going to be a mean here, that is x s bar, there is going to be another mean here. Now, we have the overall mean here. So, what is the sum of squares between these two? That is given by x s bar, that is the mean of this data, x double bar is the overall mean, square it, n is how many data points are there? There are 5 samples, right. So, 5 here, in this case both you have 5, you can have different sets also. Okay. So, 5. So, when I do for male, I will take the average which I calculated for male, subtract from the overall mean, then multiply by 5, plus I will subtract the average of the females here from the overall mean, square it, then again multiply by 5, add those, that will call the between sample sum of squares. Understand? Between sample sum of squares. Now, between sample sum of squares, okay, so this is, there will be 2 samples only here. Suppose I had say 3 drugs, or if I had male, female and infant, then I may have 3 sets of samples, then I will have 3 terms which needs to be added. Okay. Here where I am adding. Okay, within sample sum of squares, so that is called more like an error, within sample sum of squares, how do I do? So, I have a mean here, that is x s bar, subtract each one of these, okay, square it up, then add it up, then I will have an average here, mean, subtract from each one of these, then square it up, add it up. So, there will be 10 data points coming here, right. You understood? So, there is a mean here x s bar, subtract from 16, square it, then mean here, subtract from 14, square it, there is a mean here, subtract from 19, square it, there is a mean here, subtract from 16, square it, there is a mean here, subtract from 13, square it, add all of them. Now, there will be another mean here, subtract 19 from that, square it, another mean here, subtract from 24, square it, another mean, subtract from 22, square it, another mean, subtract from 17, square it, another mean, subtract from 20, square it, add up all of these. Okay. That is called the within sample. So, the excess you select, if it is for male, you will take the average which you calculated for male, if it is the female, you take the average from the female. summation over 10 data points, because there are 10 data points, whereas when you are doing between samples there are only 2 sets, because you have a mean here, you have a mean here, you are subtracting from the overall mean. So, there are only 2 terms which you are adding. You understood how to do that. Okay. So, the degrees of freedom for samples or groups will be 2 samples, 2 minus 1 is 1, understood. Okay. The degrees of freedom for total, we have say 5 plus 5 10, 10 minus 1, that will be 9. Okay. So, within samples will be 9 minus 1 8. Okay. So, here your H naught will be sigma 1 square is equal to sigma 2 square, but then that means there is no difference, whereas HA will be sigma 1 square less than sigma 2 square, that means male slept less than female. Okay. HA we can do at 95 or 99 depending upon what you want to take it up as. Okay. So, that is what we are doing now. So, I took the same male data, female data. Okay. Average of male is 15.6, average of female is 20.4, the global average, that means you add up all these and divide by 2 you get 18. So, X double bar is 18. Okay. X double bar is 18. Okay. So, if I want to calculate between sum of squares, between sample sum of squares, so what do? I subtract from the global average, in fact that is what I am doing. So, 15.6 minus 18 square multiplied by 5. Why do I need to do 5? Because there are 5 data sets here, and this one how do I get? I get 20.4 minus 18, that is 2, 4 into 5, that comes out to be 28. So, if I add, that will give me total of between sum of squares here, between the samples, understand. 2 data sets will be there only. Okay. So, how do I get this? So, I know the average of all the males, I know average of females, I know the global average, that means total average. So, I will subtract 15.6 minus 18 square it, multiply by 5. Okay. So, this is approximately about 2.5, so 28.8. Then we have 20.4 minus 18 square it multiply by 5. So, this will give you total of between sum of squares. Okay, how do I calculate total sum of squares? What is total sum of squares? For each one of them I subtract from the global mean, square it up. So, what do I do here? This is the global mean. So, 13 minus 18 square. Okay, 13 minus 18 5, 5 into 5 25, you understand. 20 minus 18 is 2, 2 square is 4, 16 minus 18 is 2, 2 square is 4, 17 minus 18 is 1, 1 square is 1, 19 minus 18 is 1, 1 square is 1, 22 minus 18 is 4, 4 square is 16, 14 minus 18 is 4, 4 square is 16, 24 minus 18 is 6, 6 square is 36, 16 minus 18 is 2, 2 square is 4, 19 minus 18 is 1, 1 square. So, I add up all these, that will give you total sum of squares. Okay. That is the total sum of squares I got. So, I got between sum of squares, I got total sum of squares. Okay. Now, within sample sum of squares, how do I do? Okay. So, within sample sum of squares, as I said here, okay. So, for each set of samples, okay, I will subtract from this, I square it up. Between sample, within sample, I will subtract from the mean of each sample set and square it up, right. So, I will do 13 minus 15.6 square, okay, 16 minus 15.6 square, 19 minus 15.6 square, 14 minus 15.6 square, 16 minus 15.6 square, whereas here I will do 20 minus 20.4 square, 17 minus 11.56 square, 22 minus 2.56 square. Okay, so, I will get if I add up all these, I will get total of within sum of squares. Okay, for between you have a degrees of freedom of 1. For total, as I said, there are 10 data points, 5 male, 5 female. So, degrees of freedom is 9. So, within will be 9 minus 1 8. Okay, so, if I want to do average sum of squares for between, what do I do? Okay, this is between 57.6 divided by 1 is this. If I have the total degrees of freedom is 9, within is 9 minus 1 8. So, 50.4 divided by 8 is 6.3. So, we have between, we have within, and as I told you, within is generally called error. Okay. Within is generally called error, between is actually looking at two different data sets. Okay. So, what do I do? Between divided by the error, 57.6 divided by 6.3, I get 9.14. Now, what will be the F table degrees of freedom? Numerator is 1 degrees of freedom, denominator is 8 degrees of freedom. So, I look into the table of F 1 comma 8 for so I look under 1 comma 8, okay, for p is equal to 0.05, 5.32, okay, 5.32. F calculated 57.6 divided by 6.3 is 9.1. So, you reject the null hypothesis. Do you understand how to do this problem? Okay. So, it is not very difficult to do, it is quite simple to do actually. The most important point is you need to understand two important concepts. Concept number 1 is we have one sample set, another sample set. In this case it is male, female, it could be drug A, drug B, okay. It could be anything, operator 1, operator 2. So, that will be called between, and this variation is called within. So, we are dividing between by within to get f value. Okay. So, you are dividing between and within to get the f value, and then that is what you are comparing with the table. Now, the question is how do you calculate the between and within? So, there is something called total sum of squares. Total sum of squares is I take average of this data set, I take the average of this data set, okay, and then I take an average of both these, that is average total of the entire, or it can be, we will call it global average. Okay. So, that global average, subtract it from each one of these terms, square it up and add all of them. So, there will be 10 sets of data here, okay. That is called the total sum of squares. So, the degrees of freedom for total sum of squares will be, because I have 5, 5, 10, 10 minus 1 is 9. So, the total degrees of freedom will be 9. Okay. Now, how do I calculate between samples? What do I do? I know an average here. So, that is average. So, that average I subtract from each one of these terms, square it up, add up, and then for the female I have an average. So, I subtract from each one of these terms, square it up, add up, then multiply by 5 here, because there are 5 data points, then add up the overall, that will give me the between sample sum of squares. Now, the degrees of freedom is 1, because I have 2 sets of samples or 2 groups, male group, female group. So, I will divide by 1. Now, how do I calculate sometimes I need not calculate within sample also, because in this particular case total sum of squares minus between sample sum of squares will give me the within sample sum of squares, and the degrees of freedom for this will be 8, because total will be 10 minus 1 9, between will be 2 minus 1 1. So, 9 minus 1 is 8. So, within sample will have a degrees of freedom 8. How do I calculate within sample sum of squares? Okay. It is quite simple. So, within sample sum of squares I will subtract, okay, from each one of these terms here, okay, and then square it up. So, I have an average minus global square and 5 term, that will give me the between. On for within, I will from the average I keep subtracting for each one of them, square it up, there will be 10 terms, because 5 for here and 5 for here, that will give me the within sample sum of squares. Understand? So, these are the numerics of this. So, I have the time taken by the male rats in minutes, time taken by the female rats in minutes. I take the average, I sum it up, divide by 5, sum it up, divide by 5. Now, the global average will be sum it up, divide by 2. Okay. So, between sample sum of squares, how do I do? 28.8 minus 15.6, sorry, 18 minus 15.6, square it up, okay, and then so 18 minus 15.6 square root up multiply by 5. For the female 18 minus 20.4 square root up multiply by 5 this. So, total of between this plus this okay, you understand. So, we get 20.4 minus 18 okay, that comes to 1.6, 2.5, then multiply by 5 that should come here. Similarly, here 15.6 minus 18 that will come to 2.4 square it up okay, and then multiply by 5 you will get this answer actually. Then you add all these this. Degrees of freedom will be 1 because we have male rats and female rats, 2 data, 2 groups. So, 1 is the degree of freedom. Now, if I want to do the total sum of squares, what do I do? Every point I subtract from the 18 because 18 is the global average, square it up. So, 13 minus 18 subtract square, like that I do. So, I will get the total for each and then add up all, this will be the total sum of squares. Okay. The degrees of freedom for total sum of squares is 9 because we have 10 data points. And then how do we do the within sample? Basically you do each one of them, compare it with the group or sample average. So, 15.6 minus 13 square, 16 minus 15.6 square, 19 minus 15.6 square, like that you get. Here it will be 20 minus 20.4 square, 17 minus 20.4 square and so on. You add up all of them, that will be total of within. Now, this is like an error sum of squares and this is like the group effect, whereas this is like an error effect. Actually, if you add up these two you will get the total sum of squares. Now, between, because we have 2 sets of groups, we have degrees of freedom is 1 okay, and for the total as I said degrees of freedom is 9, for within 9 minus 1 is 8 and the F ratio will be 57.6 divided by 1, that is the average 57.6. Here it is 50.4 divided by 8, that comes to 6.3. So, the F ratio is 57.6 divided by 6.3, that comes to be 9.14. If you go to the F table for p is equal to 0.05, 1 degree of freedom for the numerator, 8 degrees of freedom for the denominator, it comes to 5.32. So, this table value is less than the F value calculated. So, we reject the null hypothesis. Okay. So, it is quite simple problem to do. The softwares Excel or the GraphPad will not be able to do. If you give the F value, the GraphPad or the Excel can calculate what will be the p value, or if you give the p value it will give you the F value as 5.32, but this type of calculations it cannot do. But there are commercial softwares which can do this type of calculations and tell you. It is not very difficult, so you just put it on Excel, we can do that. This is called a one-way ANOVA because you are comparing the male with the female rats, male rats with the female rats, okay, that is the one way ANOVA. The most important point which you need to keep in mind is the within sum of squares should be quite small, okay, so that when you do the F ratio you are doing the between divided by within, it should be sufficiently large, then only your value will be much larger than the table value. If the error sum of squares is very large, or if the degrees of freedom for error is small also, your denominator term will become large. So, the F value will not be large. So, you will not be able to differentiate between 2 sets of groups or 2 sets of samples. So, you need to keep that point very much in mind. Okay. So, this is an interesting problem which can be attacked with one way ANOVA. Now, the same problem can be done as a 2 sample t-test also, because we have 2 sets of samples, right. So, we can do it as a 2 sample t-test. Okay. Before that I need to show this ANOVA table which is sort of a summary of the whole thing, it is very nice. So, between we have a degrees of freedom of 1 and the sum of squares is 57.6, okay. Sum of squares is 57.6, degrees of freedom is 1, mean value is 57.6 by 1, 57.6. total is 108, okay. Degrees of freedom for total is 9, so total is 108, degrees of freedom is 9. Now within that is within sum of squares is 50.4, degrees of freedom is 8, okay. 50.4 degrees of freedom is 8, so the mean value is 50.4 by 8, 6.3. As you can see here, they will all add up, df of gender and within gender it will come out to be 9. If you add up the sum of squares, these two will come out to be 8. So this is called a summary table. This is very important. You will come across this in many when the softwares run, and when you do the f value you are doing 57.6 by 6.3, that comes to be 9.1. The f table for 1 into 1 comma 8 is 5.32. So we reject the null hypothesis, okay. So this, after this preliminary calculation, we need to prepare this ANOVA table. This gives you a summary, and we can do this nice looking calculation. It tells you the whole story, and as you can see, if I add up the df of gender and the error, within gender is called error, it will give you the total. Similarly, sum of squares, if I add up between gender and within gender, it gives you the total, okay. So this is very important. Even if you do this calculation which is in the background, you need to give a summary table, ANOVA table, which tells you in one shot what is the status of your analysis. Now the same problem we can do it using 2 sample t-test also, right, 2 sample t-test also. So same problem, I can do it in the 2 sample t-test. Of course we can use Excel or we can use both the commands and see what do you get. Okay, so we use the Excel, we can copy this, Control C, so we can do it here, okay. Okay, so we say TTEST array 1 comma array 2 comma, so it is a one tail test because we want to know whether female rats sleep longer. Then type, one means paired, if you remember, 2 means equal variance, 3 means unequal variance. Let us try 2 for example, that means equal variance, so it gives you 0.008, okay, as your p value. So obviously p is very small, we reject the null hypothesis. Let us do the other one, unequal variance also, this comma one tail comma 3, that is unequal variance, okay, also we can do. So you can see you will get different p values, but still in both the cases and the p value is very small, so we can reject the null hypothesis, okay. We can use the GraphPad software also and check it out. So the GraphPad software, as you know, so that is the t-test we do, continue, compare 2 means, continue, okay. So we can say group oh sorry, yeah. So we will do this, Control C, Control V, then go again and Control C, Control V, okay. So it is an unpaired t-test, it is not a paired t-test, okay. Calculate now. So obviously as I said, GraphPad gives you only a 2-tailed test, but it is giving you a p value, so we can divide this p by 2 for a one tail, so that comes out to be 0.0082. That is what we also got it, right, 0.0082. So the difference is considered to be statistically significant, okay. So we can use a 2 sample t-test also, okay, and solve this problem. but I am later on going to show you that sometimes ANOVA is much more accurate in some situations than 2 sample t-test. Okay, but this particular problem in whether you use ANOVA, whether we use 2 sample t-test of equal variance or unequal variance, we see that p value is very small, 0.008 in that order, 0.0082 like. So, we can reject the null hypothesis, but in some cases we find ANOVA may be more accurate. So, I talked about one way ANOVA, which is very useful, quite powerful. We can compare different groups. In this particular case the groups were male and female, so degrees of freedom was 1. Okay. We are talking about male and female, so we have male and female, the degrees of freedom is 1. Then we calculated total sum of squares, which is calculated from the global mean. X double bar is a global mean. So, we will say 13 minus global mean square, 16 minus global mean square, and so on. That will give you a total sum of squares. The degrees of freedom for total sum of squares is 9 because there are 10 data points. When we have 2 sets of samples or groups here, the degrees of freedom is 2 minus 1 is 1. So, if I want to calculate between sum of squares, sample sum of squares, what I will do? Okay, I will have a mean here, so that mean minus global mean square, but I will multiply by 5 here because there are 5 data points. Then this mean minus global mean square multiply by 5, add both, that will give me the between sample sum of squares, and the degrees of freedom is 1 here. Now, if I want to calculate within sample sum of squares, I will have a mean for male alone. Every time I subtract from each one of these data points, square it up, sum it up. Then for the female, I will have a mean here and subtract from each one of these data points, square it up and sum it up, overall summation. Okay. So, here I will do that. The degrees of freedom for within sample is the total is 9, between sample is 1. So, within sample is 9 minus 1 is 8. Okay. Okay. So, I have the ANOVA table. So, total I told you how to calculate, the degrees of freedom is 9. For between sample or between gender sum of squares, I know I have only 1 degree of freedom. I divide this term by this term to get mean. My variance estimate within gender, the degrees of freedom is 8. I know how to calculate, I told you, divide by 8, I will get this. F value is ratio of this by this, and F table is given by 5.32 for 1 and 8 degrees of freedom. Then I compare the F table value with the F value calculated, and in this particular case I will say I will reject the null hypothesis. So, this one way ANOVA is very powerful. So, instead of male female I could also have an infant. So, there I have 3 groups. 2 sample t-test is very difficult to do. Either I take a male and female alone, female and infant alone, male and infant alone, and do the 2 sample t-test, or I have to use a one way ANOVA. So, I have 3 groups. So, the degrees of freedom will be 3 minus 1 2 in this particular case. Okay. So, I can use the ANOVA, which is very powerful to analyze that sort of data. So, the H naught will be sigma 1 square is equal to sigma 2 square is equal to sigma 3 square. That means 1 means male, 2 means female, 3 could be infant. Okay. And HA could be if I am looking at some difference, it could be sigma 1 square not equal to sigma 2 square, one of them is not equal to. Okay. So, let us continue with the more of this one way ANOVA, and we will look at one more problem in the next class. Thank you very much.